Welcome to Heating and Ventilation Done Right, written by SHB Consulting and produced by The Training Factor. A heating and air conditioning system is designed to provide a comfortable temperature and humidity level within a building. The ventilation system circulates and filters conditioned air within the building. In certain applications, mainly commercial spaces, outside air is added to improve indoor air quality. The ideal HVAC system is energy efficient, cost efficient, and low maintenance. There are many different HVAC systems, but they have some common design elements. Air Handling Unit, AHU, typically includes a blower motor, heating element, heat exchanger, evaporator coil, and humidity condensate catch basin or pan. Outside air intake, an opening through which outside air is brought into an air conditioning system or into a boiler room, which is usually found in commercial applications. Return air system with filtration medium, a duct system for returning air from the residence to the AHU for filtering and conditioning. Air distribution or supply system, insulated duct system for supplying conditioned air from the AHU to the residence. Flue gas exhaust system, safely removes combustion gas exhaust from the AHU and the residence. Exterior compressor unit with condenser coil, exterior equipment for the air conditioning system. The compressor pressurizes the refrigerant and the condenser coil removes the latent heat from the residence. The air handling unit draws air into the HVAC system through the return air intake system. In the HVAC system, the supply air is filtered to remove dust, mold, and allergens. The AHU then heats or cools the air depending on the season. The air distribution system, which is typically composed of supply ducts and registers, then circulates the air throughout the building. As noted, the air distribution system includes a return air system. With the return air system, air within the residence is returned to the AHU. It is then filtered, conditioned, and circulated back to the residence through the supply air system. This process takes place by drawing air from the occupied space and returning it to the AHU. Maintaining proper ventilation for combustion systems. Anytime you maintain, retrofit, or replace a gas heating system, you also need to be concerned with air quality. Combustion air is needed by all oil and gas heating systems to support the combustion process. This air is provided in some buildings by unintentional air leaks, by air ducts that connect to the outdoors, or by placing the equipment in small mechanical closets with louvered doors or in large mechanical rooms. The combustion process creates several byproducts that are potentially hazardous to human health and can cause deterioration of the physical asset. You can protect against these hazards, as well as maintain energy efficiency, by ensuring that the chimney system functions properly and that the gas heating system is properly ventilated. In some cases, installing a sealed combustion furnace or boiler can also help. Properly functioning chimney systems will carry combustion byproducts out of the building. Therefore, chimney problems put you at risk of having these byproducts, such as carbon monoxide, spill into the building. Most older gas furnaces and boilers have naturally drafting chimneys. The combustion gases exit the home through the chimney using only their buoyancy combined with the chimney's height. Naturally drafting chimneys often have problems exhausting the combustion gases because of chimney blockage, wind, or pressures inside the building that overcome the buoyancy of the gases. Welcome to Air Conditioning Done Right. History of air conditioning. Air conditioning has changed the world forever. It is now built into our culture and our economy. This class will teach the basics of air conditioning. Let's begin by touching very briefly on the history of air conditioning. Air conditioning is built on the laws of thermodynamics. The law of thermodynamics states that heat is a form of energy. Heat energy will always move from a place of high intensity towards a place of lower intensity. Thus, heat will always flow to something with less heat. Ancient empires took advantage of this principle to form a type of air conditioning system. In ancient times, workers would take large stone blocks out of the palace walls and homes to the desert. During the cool nights in the desert, the large stones would cool. In the morning, the workers would bring the large stones back and reset them in the wall. Hence, as the interior heated up during the day, the heat would be absorbed by the cool stones, lowering temperature inside the palace or home. Do you see how this simple practice takes advantage of the laws of thermodynamics? First, the warm stones would cool in the desert at night. Then, when the stones were restored to the wall, the heat from the interiors would be absorbed by the stones, which would produce a cooler living environment. Although systems today are more complex and more efficient, the same principles apply. Rotary fans added efficiency. When do you think rotary fans were invented? 2nd century, medieval days, 1700s. That's incorrect. Try again. Rotary fans added efficiency. When do you think rotary fans were invented? 2nd century, medieval days, 1700s. That's correct. In the 2nd century, Ding Huan, an inventor in China, invented a rotary fan for air conditioning which contained 7 wheels. Please make note the direction in which the refrigerant flows in an air conditioner. We will start with the condenser, which is located outside. The refrigerant flows through the compressor into the condenser coils, out of the compressor unit into the liquid line. It now travels to the air handler, which is located inside the building. The refrigerant goes through the metering device and then enters the evaporator coils. As it leaves the evaporator coils, it enters the suction line. The suction line goes into the condenser in the outside, and the cycle begins once again. Now let's review.